Unit 9b4 is about calculating voltage, and yes, that means we're going to be doing some math. Us professional light designers need to occasionally work with some watts, some big watts, some bulbs that have a lot of wattage. And when we're pulling a lot of wattage through an electrical circuit, we need to make sure we don't overload that circuit for safety reasons. So we're going to have to do some math in order to make sure that we keep safe. And this unit is going to teach you how to do that math. It's nothing outrageously complicated, and I'll show you some practical examples of how that math is going to work. But you will need to be able to do these equations for the tests in this class, so make sure to pay attention as we learn to calculate voltage for video production. First of all, I'm going to define a couple of terms. An ampere, which we're just going to call an amp, is a unit of electrical power. It's how much power we need, an amp. Then a volt is another thing we're going to talk about. Technically, if we want to get scientific, a volt is how we measure flow of electricity, but for this class, we don't need to worry about exactly what that means. We just need to know how to work an equation with amps, volts, and watts in it. Watt is another technically different term that means work energy used, how much energy is necessary to do a particular act, like make a light bulb stay on, for instance. But all you really need to know is that amps, volts, and watts are all important, and you need to be able to figure out where these numbers are on your bulbs and stuff like that, and then how to plug them into a formula, which I'm about to show you. So let's define a few more things here. United States uses some standardized electrical formats, and I'm in the United States, so this lesson is customized for US standards. First of all, an AC socket is a device where we plug in appliances, and the standard for AC sockets is 120 volts per outlet. And so that means every outlet, like this outlet for instance, and that outlet for instance, pull 120 volts of electricity in the United States. Oh, and AC, by the way, stands for alternating current. That's the way that all electrical grids work, all electrical mains work in all countries on planet Earth. So here's some typical sockets in the United States. The one on the top is facing sideways, the one on the bottom is facing down, but they're the exact same socket. All right, a few more things. Now let's talk fuse boxes. Somewhere in your house or business or studio or wherever you're doing video production, there is one of these boxes. This fuse box is where all the sockets come together for fuses. Each of these fuses has a bunch of sockets connected to it. So there's the definition of fuse box. All the sockets are wired to fuses. And then a branch is a group of sockets connected to one fuse. In the photo of the fuse box, you can see a bunch of fuses. Each of those black rectangles is one fuse, and each of those fuses represents one branch. So branching out in the wires behind each of those fuses is a whole bunch of different sockets. Depending on how your facility is wired, the sockets could be different in different places, and you might have different amounts. Now, the strength of each fuse varies. So some fuses are as small as 10 amps, some can take up to 30 amps. And it makes a big difference if you're in a business or a home, how many amps your fuses are connected to. So if you're going to do video production work, you might have to find that fuse box and check out the rating, the amp rating on it, to make sure you don't overload the circuit. I'm going to show you what all that looks like in just a minute. So let's start with the problem that we're trying to avoid. If you pull more amps from a branch than its fuse is rated for, that means you're trying to pull more electricity than that fuse is rated to be able to deliver, then you're going to blow the fuse. The danger here is you could risk an electrical fire. So this is important. This is a safety hazard that you need to be aware of when you're bringing professional video lights into any kind of scenario, especially in a home where you might have small ampage rated fuses. Okay, so professional lights can require a lot of amps. How many? Well, check out this chart. This comes from a typical light kit that can be checked out and used in a variety of locations. These are all the different bulb options for this. In this case, is a Toda light. If you look on that chart under volts, you see 120, 120, 120. These are all different kinds of bulbs, different size bulbs that this same light fixture will hold. This Toda light can have all these different kinds of bulbs. And then to the right of that, it lists the wattage for each one. So the very first bulb that we could put in here is 120 volts and 300 watts. It's 2900 degrees Kelvin. I'll explain color temperature in a future lesson, so we can skip Kelvin for now. The code is just going to help you buy it. So when you're finding that particular bulb, that code can help you track it down. And then this one even breaks down the ampage. So that's 2.5 amps for that 120 volt, 300 watt bulb. But notice this particular light fixture can take bulbs that are 500 watts, 650 watts, 750, or even 800 watts. Notice on the bottom of the chart, the 800 watt bulb requires 240 volts. In the United States, you can do special electrical outlets that do 240 volts. You might have one in your home next to your dryer, for instance. Those are unusual. All right, so let's talk about some fuses. Let's go look at the fuse box. In our fuse box, we can see that this is a 20 amp fuse. So when you look closely, you see that little number 20 on there. Here's a 30 amp fuse. They look the same, except for until you look closely, one's got a 20 and one's got a 30. That's how many amps that fuse can take. So those two different fuses can take very different amounts of bulbs, amounts of electricity pulling from them. All right, so how are we going to solve this problem? Of course, with math. And here is the formula. Watts divided by volts equals amps. And the easy part of this formula is the volts, because in the United States, we're always going to assume that every outlet is 120 volts. So the volts part of the formula is done for you, 120. All you need to know then is the wattage of your bulbs. Add them all up, and you get your total watts, and divide that by volts, which is 120, and then you know how many amps you're going to need to power all that stuff. Let's try applying that formula in some sample scenarios. Always remember that watts divided by volts equals amps. Okay, first scenario, we want to plug in that bulb right there. This is a typical kind of a bulb that you might use in your house. We don't use these for professional video production, but if you look closely, you can see this one says 40 watts. All right, so if we want to plug in a new bulb, and that bulb is a 40 watt bulb like this one, and we're always going to assume 120 volts, then our formula looks like this. 40 watts divided by 120 volts gives us an answer of 0.33333 repeating. I didn't put all the threes because they go to infinity. We can round that off to 0.3 in our case, just round that down, and so we know that one 40 watt bulb requires 0.3 amps to run. Well, the smallest fuse in our house is 10 amps. So with 10 amps on one branch, no problem. We can plug in a whole lot of those 40 watt bulbs. How many? Well, let's see. 0.3 goes into 10. I think that's about 30. We could plug in about 30 40 watt bulbs on a 10 amp branch and have no problem of overloading it. So that's not a worry. Now, let's apply this formula in a typical video production scenario. Always remembering that watts divided by volts equals the amps, and we want to plug in this bulb. Looking close at the bulb that we checked out of our light kit, we can see that it says 120V and 300W on it. Well, the 120V is a standard. That's the 120 that all United States bulbs have to work at, but the 300W, that's wattage. That's a whole lot more than the 40 watt bulb we had in the last lesson. Now we're working with a bulb that's 300 watts. And of course, we want 3 of them because this is a 3-point light system that we're setting up. So we've got 3 different light fixtures, each one with a 300 watt bulb. And so 300 bulb, 300 watts, 3 of the total bulbs. We're talking about 900 watts we need to pull through our electrical system here to power these 3 bulbs. Let's calculate whether or not that's safe. In our formula, we always assume 120 volts for the United States, and that's going to give us these numbers here. 900 watts divided by 120 volts equals 7.5 amps. 7.5 amps are going to be required from this branch to run these 3 lights. And since the smallest fuse we know is 10 amps, we don't have a problem here. We're going to be okay with these 3 300 watt bulbs. That's the first scenario. We're all good here. Scenario 2. This time, always remembering that watts divided by volts equals amps, look at our bulb. This one is a 500 watt bulb. And I turned this one sideways because when you're looking at bulbs, you often have to find yourself peering into small spaces and seeing things upside down and sideways. And with tiny print, get used to it, video light designers. So we got 500 watt bulb. And of course, we want 3 of these things for a 3-point light system. 500 watt bulbs. 3 bulbs times 500 watts each equals 1500 watts total. Always assume 120 volts because we're in the United States and plug the numbers into our formula. We get 1500 divided by 120 equals 12.5 amps. That's how many amps we're going to need to run all this. All right, so that's what it says there, 12.5 amps. The smallest fuse is 10 amps, and that means we better check the fuse box. And that means, sports fans, you've got to climb around your house or studio or scenario or wherever you are, find the nearest fuse box, figure out which branch is serving the outlets that you're using, and make sure it's more than a 10 amp fuse, or else you're going to have a hazard here. You're going to blow a fuse. Best case scenario, worst case scenario is you're going to cause a fire. So you need to find that fuse box and make sure the right kind of fuse is connected. By the way, if you only have a 10 amp fuse and you're trying to plug a bunch of lights into it, try spreading the lights out. Use electrical cords and plug them into outlets that go to different branches. As long as you can use more than one branch, then you can get down underneath that amperage rating for each branch. Okay, there's the formula. You're going to have to use this in some tests, so make sure you have these lessons down pat and be ready to test yourself on how this is going to work.